Again, last class we have seen the importance of pH and all, right? So today we will see the pH of salts and the common salt. Okay, pH of salt. You know that when acid react with base, you will get, this is a neutralization process. Acid plus base will give salt plus water, right? Okay. So this is neutralization, this we call this as neutralization process also. That means neither it is acidic nor it is basic, right? So when strong acid plus strong base reacts to form salt, right? Salt plus water. This salt pH would be 7. That means it is neutral. Neither acidic nor basic. Okay. Okay, what happens to the pH of the salt when a strong acid reacts with weak base? Strong acid reacts with weak base means the salt will be acidic in nature, right? So you know that there's a pH scale, right? 0 to 14, and here you will have 7. Strong basic acid means what? It will lie. This is 0, right? Strong base, it reacts with weak base means it will be acidic in nature only, right? Acidic in nature. So obviously the salt nature would be acidic in nature, and it will be, the pH will be less than 7. It comes in this part. Okay. Likewise, when the strong base react with the weak acid, it gives salt which is basic in nature, because strong base means it lies between 7 and 14, right? So if you even add the weak acid, it will be basic in nature only. So the pH will be greater than 7. Okay. When the strong acid and strong base react, you will get the salt with a pH 7. It is neutral. Strong acid plus weak base means the acidic nature will be dominating in that. Okay. So the salt nature will be acidic in nature. So pH would be less than 7. Acidic means pH will be less than 7. Strong base plus weak acid means basic in nature. The pH should be greater than 7. Okay. Coming to the common salt. So you know that how the salt is common salt is produced. You can produce the whatever you are using, the NaCl, sodium chloride, right? How it obtains in HCl reacts with NaOH. It gives acid plus base will give salt. Salt is this will combine, and these two will combine, right? NaCl plus H2O, right? Okay, this is how you will obtain the salt. Okay, but whatever the salt, the seawater contains more salts, right? So whatever the salt, to differentiate from the salt obtained from the seawater and the chemically produced, we'll give the name the salt obtained from the sea as common salt. Okay, just to differentiate from that. Okay, common salt. Sodium chloride obtained from the sea is known as a common salt. Okay. So most of the places you can see the beds of the salts is there, right? Due to the ages, bygone ages, you will get the beds of the rock become big rock salt. Okay. It becomes a big rock. Okay. The salt obtained from the sea contains impurities, hence it is brown in color. It will not be white in color. They will purify and will give it for the daily use. But once it is obtained directly, whatever it is obtained from the sea directly, it is brown in color due to the presence of more impurities. Okay. This salt is called rock salt. Okay, the salt which is brown in color, that is contains impurities obtained from the sea, is called rock salt. Okay, the beds of the rock salt were formed when seas of bygone ages dried up. Okay, when the sea has gone up, by the time it becomes a rocks. Okay, beds of rocks of salt. Okay, the rock salt is mined like a log. How we do the mining of coal. Likewise, we'll do the rock salt also mined like this. Okay, from the beds of rock. Next, so we have so many importance. This common salt plays a important in the freedom time also. When you are fighting for the freedom, right? So Dandi March is there, right? So it has a more important role in the daily life, because this used as a raw material for production of so many chemicals. Okay, that is used in our daily life. Okay, so common salt is used as an important raw material for obtaining many chemicals and for our daily use. Okay, so we have so many chemicals formed with the sodium chloride as a raw material. Okay, one of the thing we will see today is sodium hydroxide. Okay, sodium hydroxide. We are going to produce sodium hydroxide with the salt as a raw material. Okay, so how it is produced? Sodium hydroxide is produced is by the chlor-alkali process. Okay, we'll call this process as chlor-alkali process because the product formed is chlorine and alkali. Base is formed, sodium hydroxide is formed. So hence it gets a name. Okay, so what is this process means? When electricity is passed through an aqueous solution of sodium chloride, because sodium chloride is the main raw material. Okay, aqueous solution means what? The solution is the sodium chloride is mixed with water, aqueous solution, right? So we'll call this as NaCl, sodium chloride plus water as a solution. No, we'll call this as a brine solution. Okay, usually we'll call this as a brine solution. Okay, when you pass electricity over this aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. Our main aim is to produce sodium hydroxide. Okay, this process is called chlor-alkali process. Why it gets a name? Because in the products, the byproducts would be chlorine and alkali, this sodium hydroxide. Okay, so your chemical reaction would be NaCl plus H2O gives NaOH plus Cl2 plus H2 upon passing the electricity. Okay. Okay, so this is your process, right? So this electricity is power is connected to this in the form of a battery. Okay, so this is anode, this is cathode. When the brine solution, brine means what? It is NaCl plus H2O. When it is passed inside, it decomposes to form, this NaCl is decomposed to form Na plus and Cl minus. Okay, Na will be separated in this cathode ion and Cl is attracted to the anode, right? Na plus and Cl minus. So what happens here means, this Na plus, right? This is an ion. Okay, what it will do? It has one electron in the excess, right? So it will release the electron. Na plus gives one electron to form a metal, sodium metal. Okay. Okay, now this sodium reacts with the water present in that. Okay, water present in that to form NaOH. Okay, NaOH plus H2 gas. Okay, the H2 gas will be collected in the cathode side. Okay, and NaCl decomposes to form Na plus Cl minus. Okay, this Na will release one electron and lose one electron and form a metal, right? This metal reacts with water to form NaOH plus hydrogen gas is released at the cathode. Okay. Okay. So what happens to this Cl minus means it receives one electron. It needs one electron, right? So one to complete that. Okay. So it receives this electron and it became a Cl, fluorine. Okay. So it does not exist in Cl, it exists in the molecule form Cl2. So this gas is released at the anode. Okay. So when sodium chloride is decomposes, what are the byproducts formed? When it is passed and it is decomposed, you will get chlorine gas, hydrogen gas and sodium hydroxide. So three main important products you got at the at the end of the chlor-alkali process, right? So what is that? Sodium hydroxide solution, chlorine gas and hydrogen gas. So all these things are very important for so many purposes. Okay, so we will see one by one. Okay, uses of chlorine gas. Okay, mainly you know that chlorine gas in the lower classes you have studied, it is used for water treatment process, for disinfection process, right? Killing the germs and bacteria. Okay, and same reason it is used in the swimming pool and also used as a disinfectant. And in the production of PVC pipe, chlorine plays an important role. and also the chlorofluorocarbons, CFCs, and also in the production of pesticides. Okay, so these are the main use of chlorine gas which is produced from the NaCl decomposition. Okay, next, uses of hydrogen. Hydrogen gas, we know that it is used as fuel. Okay, and also it is helps in the for making of ammonia for fertilizers. And this margarine is nothing but your butter, that is artificial butter. Okay, that is made up of vegetable oil. Okay, when the vegetable oil is converted into semi-solid or solid form using the hydrogen gas, we will get a butter like substance. Okay, that is margarine. Okay, then uses of sodium hydroxide. So you know the maximum base is used for the it is highly corrosive in nature. It is used for the unblocking of the drains and all you will be using, right? So it is used for degreasing metal. Okay, removing the greases. Okay, and used in the making of soaps and detergents and paper making and artificial fibers. Okay, these are the uses of NaOH. Okay, we'll continue with the more chemicals from the salt in the other class. Thank you.